Welcome to Microsoft Build 2017. My name is Shamik, and I'm a product manager on the data migrations team. This is my colleague, Alex, who is a developer on the data migrations team. Today, we will talk about how you can migrate your Oracle database to Azure SQL database using the new database migration service. So let's start. Let's actually quickly discuss what are the important steps for every database migration. So there are three key steps for every database migration, and they start with assess, they go to migrate, and then you do optimize. So essentially, what does assess mean? In assessment, you would identify what changes are required on your source database. So if you're moving from Oracle, you want to analyze the schema to find out what converts, what does not convert to SQL, and then make changes to it if you want to. So in the second step, when you do actually migrate, you start off with the first step, which is schema deployment, because it's critical for the schema to deploy in Azure before you start moving data. Once the schema is deployed, you would still probably need to do some migration fixes. What I mean by migration fixes is, let's say a procedure did not convert, a trigger did not convert. You would actually want to go and make those modifications on the target server. Now, once everything is over, you would then migrate your data. Now, the bug doesn't stop at data migration, because the next step is actually optimization. SQL memory engine works very differently in correspondence to how Oracle works. So there will be a couple of memory optimizations, query optimizations that you would have to do on the SQL side once the data migrates over.
And SQL might have more features that tune your performance than Oracle does, so you might consider using those on your new database.
That is correct. So without wasting any more time, let's actually get into some demos.
Yeah, let's see how you can do it.
All right. So as I said, for the focus of today's session, we will focus on assess and migrate. And we have two tools that our team builds. For assessment, we have the SQL Server Migration Assistant, which is capable of looking at an Oracle schema. It's capable of converting the schema. It's capable of deploying that schema. Then, as I said, we have the new database migration service that you could use to migrate the data over once the schema is deployed. So SSMA for the SQL for Oracle can be downloaded from https:// SSMA for Oracle. It today supports Oracle Sybase, DB2, MySQL, and Access. And you can move them over to either SQL Server on-premise, on a VM, on a database, or data warehouse. So let's quickly get into the demo. I will start off by kicking off a new project in SSMA. So I'm clicking on my Oracle Migration Assistant. I start off with a new project. Let's call the project Migrate from Oracle. And this is very important. You want to make sure that you choose the right target, because the conversions happen based on the target that you choose. So in this case, I'm choosing SQL Azure. I hit OK.
Which schema are you going to convert?
Well, I'll take the very well-known schema in Oracle. It's called the HR schema. I've doctored the schema so that it doesn't look very simple to the audience. I want to make sure that I put in something that does not convert. So let me connect to Oracle here really quickly. This is a local instance of Oracle. It's running Oracle Express. So let me connect. At this point in time, it's actually interrogating the Oracle database, and it will bring us back the schema artifacts. So let's give it.
Well, that was pretty fast.
Yeah. So let's check HR really quickly. So HR has a few functions. If you look at it on the functions node, it has a few procedures, few sequences, about 9 tables or so. So before we do anything, let's do the conversion. Before I convert, I would actually want to connect to my SQL Azure instance just to make sure that it connects.
Makes sense.
Looks like my password is invalid. So let me try one more time. And there you go. It's actually asking me to create an HR database into that instance, because I did not have the database. So the tool's actually prompting you to create the database.
That's good.
So let's go create it. It's actually giving me options to choose a performance tier. Well, let me do standard for now because this is not going to be a big migration.
Good enough for relatively sized schema.
Yep. So let's start by creating it. So Alex, would you want to explain what really happens in the background though for schema conversions?
For the schema conversion, yeah, we will have to parse all the source objects for the selected schema. We'll have to extract all the PL/SQL definitions for these objects. And then we will try to convert them into T-SQL definitions and eventually deploy it on your target server. It works most of the time, but as you might understand, Oracle is somewhat different to SQL Server. And for some of the objects and some of the syntactic constructs, we may not really have a direct mapping in T-SQL. We do try to implement a lot of emulations. For example, the regular expression functions in Oracle, they don't really have direct analogy in SQL, but for that we have emulations through CLR procedures on the SQL Server side. But not everything is covered through emulations, even though we are trying to improve it every day. So for those things, you might need to go and do some manual modifications to the schema on the target, as Shamik explained before. But for this HR schema, I think we should be good. We should be covered.
Yeah, let's
see how it goes.
Let's see how it goes. So it did create the HR database for me. I want to quickly connect using SSMS to make sure that the HR exists on the other side. And while SSMS is coming up, let's actually fire up the conversion.
Yep.
So I do it by right-clicking on HR, and I do convert schema. And let's give it some time to convert. And while it's converting, let me quickly connect to the SQL Azure instance and find out if I have this database in there or not. So looks like it was able to create the HR, but the HR does not have any artifacts. So it has no tables, no schemas populated yet.
That's because we didn't deploy the schema yet.
Of course.
Let's see how conversion goes through.
So it says the conversion finished with 6 errors and 6 warnings.
Warnings are fine, I guess. Errors are not that good.
Yeah. So it looks like this function did not convert.
Oh, can we see what's wrong with the function?
Let's look at both the SQL side of it and the Oracle side of it.
So what does the SQL side tell us?
So let's quickly look at the warning. It says conversion from number data type can cause loss, but that is straightforward because we don't have a relevant number data type.
That's correct. SQL, yeah. SQL has a difference in how it stores floating points. It's binary versus decimal float, but it's all right. Should be good. It's not that big. It's like.
Well, here it says the identifier dbms_random.value cannot be converted.
Oh, so unfortunately, SSMA doesn't convert random numbers. I think that conversion depends on where you use it, actually. Let's see what this case is.
Let me expand the window a little bit more, and you can tell me what's happening.
So yeah, it looks like they're trying to find an employee with a specific value in the skills column, and they just select a random guy from the result list.
Okay.
Yeah, so we can fix it. I think that the right way you do it in SQL is just do order by not the random value, but the new ID function.
Okay.
And I think you should be able to fix it right here, but
interesting enough, you bring this point. I was hoping that the SSMA would convert everything, but clearly this was a case where SSMA did not understand how to convert it. So
yeah, we will fix it in the next version. But for now, actually, I think we can unblock you. So one way would be,
Yeah, sure.
One way would be you just modify all this thing in line, because we actually allow you to edit the source and the target. So before you deploy the schema to the target, you can just proceed and change this DBMS random value to order by new ID, and that should do the trick.
But wouldn't that be painful if you have multiple occurrences of this? I mean, it becomes cumbersome to go to the editor here every time and make those changes.
That's a good point. But for that, I have an answer as well. So recently, in SSMA version 7.3, we introduced what we call an extensibility feature, where you actually can register your custom conversions for the syntax inside of the tool, and we will use it when you convert your schema.
So are you saying I can write my own converter?
Yes, that is correct, and I will show you how. That's not really that difficult. So for that, you go into Visual Studio, obviously, because this is where we code in Microsoft, and you create a new project, and you have to reference some of the SSMA binaries here. I'm going to go through them, but you can stop the video right now and see what you need for that. Let's move on to the custom conversion code. So let's add a new class for a custom converter, and I will walk you through and show you what you need to do in order to achieve the good conversion rate. Let's add a new class here, call it our custom converter.
Okay.
Hit enter.
Hopefully it's straightforward, Alex.
I think so. Well, it is straightforward for me. I hope a lot of our listeners will find it straightforward as well. So I already have snippets ready. So first of all, you add all the required usings in order to be able to use our built-in classes for the converter.
Okay.
Then you go and define your converter class. And what we do inside of the SSMA is we use what's known as Microsoft Extensibility Framework, MEF, to actually inject all of the custom converters into our pipeline.
I see.
So for that, you have to export your converter as an inode converter, which I believe is pretty self-explanatory. And then you have to define which node in a syntax tree you want to convert with this node. In our case, if you look at it, it is a function, and function is by definition as identifier pointing to something. So here I'm converting an identifier, and I'm saying that my converter only applies to SQL Azure, because I don't really know what happens for Azure SQL versions. Maybe there are different functions replacing this random value or whatever. So let's just move on with the SQL Azure specific converter, because we will apply it to this specific project. Then you have to define the constructors that accept the document converter, and this is the context for the conversion, which will have the whole syntactic tree of all of the objects in your database, so you can navigate back and forth and resolve some references shall you need to. And standard MEF attribute for importing constructor right here. The thing is, once you override the converter, the default one will not be applicable anymore. So in order to preserve that functionality, what you want to do is you want to create the original converter and pass through the request to that one when it's not DBMS random function. So we will do that next. And I know that our original converter is called identifier converter. So I'll do new identifier converter and pass there the original document converter so that it can operate properly. And I will store it somewhere in the local field. Let's say call it original converter. I call this guy, and all we need to do next is just define this guy somewhere so it's stored properly. I'll just call it identifier converter. That way. Now we have our original converter, and the next thing we want to know is which function we want to convert and how we're going to identify it. So for that, you have to define a name for the source function, and here I have it. So what it does is basically creates our internal construct that points to a specific function that comes from DBMS random package and is called a value. So basically it's two-part name. We have simple names for every part, and then we build a compound object name, and then we can match the functions based on this. And that is pretty reliable because we parse that in the same construct and you'll just compare them. And lastly, what you need to do is write the real meat, the real code that does the conversion. And here it is. All you have to do is override the convert node method right here. And what we will give you is the source nodes that you're converting right now. And remember, we're inside of identifier converter. So all you will get is identifier nodes, not some random select node, not some random update node, but only identifier nodes. And we will give you the target parent node where you have to hook your new converted node in the target metadata tree, and a conversion context that you can use to write traces and logs and resolve some references using our built-in linker. The conversion code itself, I will walk you through, but believe me, it is super straightforward. So first we need to do is check whether we have the right identifier as an input, because this will be called for every identifier. If you have a column or a table, that is identifier as well, so this will be called. First we do is we check whether the input identifier, the source node, is actually our random value function. And if it is, then all we need to do is create new identifier node in the target tree. So I'm doing my target parent, add a new identifier node with a very simple identifier that doesn't have three-part names or something. And I set the name for it to new ID, which is a function that gives you a new GUID and SQL Server, and we can easily order by that to get a random order every time. And lastly, all we need to do is specify that this new ID function doesn't receive any arguments, so we'll just create an identifiers parameters list, which is completely empty. And then you return your node, and you should be done. At the very end, if this function was not the one that we wanted to convert, we'll just pass it through to the original converter, and that will do its job, converting tables and nodes and resolving other functions that we don't support by this custom converter. This should be good enough, I think. Let's try to build it up and see if it works. Here it is, compiled successfully. And now with this, I will give my custom converter DLL back to Shamik and see if he can actually use it inside of SSMA and if that function is resolved after this. So here's the output of my custom converter. I grab this DLL, copy it over, and all you have to do is just drop it in the SSMA folder right here.
Where exactly? Is it in the bin folder on the
Yeah, it is in the SSMA bin folder. It should be next to the executable because this is where we scan for custom functionalities. With this, you should be able to convert your new function, I think.
You're saying if I convert now, I would not get the error?
I think you'll have to restart it because we only load it once. We don't scan it every second.
So how about this?
How about you just close the project and reopen it? I think that should be good enough.
So let me save the project first, so that I can
Makes total
reopen it
sense. Export your HR schema.
Let me save it. And let's give it a few seconds for it to save. It's done. So you're saying, let me close it now.
Yeah.
Let's start Oracle the migration assistant one more time. Let's open up the project that we had. Let's migrate from Oracle. And now, if I run conversion, I should be able to convert, right?
I would hope so. Let's see.
Let's see. Let's convert. I'm overwriting everything.
How does it look like?
Interesting. Converted now.
There you go. And what do we have in the output?
Let's take a look.
My assumption would be it's sorted by new ID that we just did. There you go. There you have it.
There you go.
And now you can apply the same conversion to the entire code base, and you don't have to go and do it manually everywhere.
That's pretty good.
All right.
I could repeat this pattern for multiple issues that I get.
It's great.
Well, now that it's converted, let's actually find out if you can push that schema to the SQL Azure instance. So let me take HR, and let me do synchronize with database. At this stage, it will ask me to connect back to SQL Server. And this should start pushing the schema over onto SQL Server. So if you look at it, it says it was not able to find the following artifacts. And as soon as I hit OK, I should start seeing the schema built up properly inside HR. So let's refresh our HR schema. In this case, database.
I only push the HR schema?
Yeah.
I think you will need to push the emulation schema as well. Remember we mentioned that SSMA creates a bunch of emulations. You will need that schema for that to work as well.
That's a good point.
Because even some simple conversions do require the emulation sometimes.
Looks like I pushed that too.
That's great then.
So let's push it one more time just to make sure that we push it through. Let's hit OK. And let it populate. So I think this takes us through to the next step. So we've made conversions. We've looked at the schema. We found out what converts, what does not. We were able to customize that conversion, and we were able to push that schema over to SQL Azure. Now, just for the audience to know, SSMA today does support migrations to SQL DB, but the new release that we're going to release very soon, we will give you the option to upload this project to the database migration service. What that really means is when you're done with your conversions and you've pushed your schema to SQL Server, you should be able to hand off the migration to our database migration service. And for that, any project metadata that's saved inside SSMA can be uploaded directly to Azure. So let's actually make sure that our schema migration is done.
There we go. There we have it.
All right, so we did push it all the way through.
Now we have to...
The schemas are there. Let's interrogate it really quickly to find out if there are any entries in there, because we just pushed the schema, so there shouldn't be any data inside it. So let's verify it before we push the button for data migration. So as you clearly see, there's no entry here.
Can move on to the data migration for that.
So this is a new feature inside SSMA. If you look at this icon right here, it says Save Project to Cloud. So let me hit that, and I will do it for my HR schema. What this would really do is it is actually interrogating my subscription. Once it interrogates my subscription, I should be able to give it an instance of my data migration service, and I'll be able to save that project to that instance.
And this data migration service is the new service on Azure that we're just releasing right now. Okay.
So I've already provisioned the service. It's called Oracle to SQL Migration. I'll get this project name here. So my project name was Migrate from Oracle. Let me hit OK. And at this moment, it's actually saving it to my DMS instance. Let's give it some time for it to save. And while it's saving, let's quickly switch over to our service. So provisioning this service should be very straightforward. It's just like any Azure service. You should be able to go to your Azure portal, search for our database migration service, and provision an instance of it. Now, I'm pushing it to the Oracle to SQL migration service that I already created. Let's actually quickly refresh it to see if it has gotten our project. So if you notice, it says migrate from Oracle.
Oh, looks great. Let's try to move data.
Yep. So let me choose that migrate from Oracle project. Let me start a new migration. Give it a name. Let's call it build demo. Maybe give it Oracle. Let's save it. Now, while it's saving, it's essentially cracking open up that project because my project has all the metadata. It has the source details, the target details, and everything else. So let's see what it does. Is it able to populate my source details directly from my project name or not? There you go. That was my local instance of Oracle. It populated everything else. All I need to do is add my password.
Hope you'll get it right this time.
Let's make sure. And these are my target details. And that's my SQL Server instance in Azure. So it looks like it knows from the context of the project that these tables have to be moved. Let's run the migration. Let's go back to our project to make sure that it's running. It is. Let's hit refresh a few times and see how much time it takes for it to migrate. But what we could really do is let's actually start querying.
See if data shows up.
Yeah.
Not yet.
Not yet. Let's give it some time, Alex. I don't think these were very small. We did put some data in it. So let's give it about half a minute.
Half a minute?
Yeah, you want to time me on that?
Sounds good.
All
yep.
right.
Let's
Let's actually see.
There you have it. It's great.
So let's refresh it to make sure that it's successful. It's still pushing in data. But as you can clearly see,
the data is there.
The data is there. So I started from my on-premise Oracle. I made all schema modifications. I pushed that schema. And with just a click of a button, I was able to upload that project and add in a few details like my password and source and target. And I was able to move my data from Oracle on-premises to Azure SQL Database.
That is impressive.
This concludes our demo. What I would really like to do as next steps for our audience would be to sign up for our service. So you can download the SSMA from aka.ms/SSMA for Oracle. You can go to our DMS preview to sign up. It is https://aka.ms SQL database-migration preview. And we have a migration blog where we always blog about new features in our tools and services that will help you migrate seamlessly to the Azure.
Sounds great.
Thanks.
Thank you for watching,
attending.
guys.
I hope you enjoyed the session. Enjoy the rest of your other sessions on Build.